All right, so today we are going to dive into Python. And today will be a review of Python and some introduction into some language features you may not have seen as much. And we're going to talk about writing tests and a little bit about test-driven development, specifically using the Pytest library for writing tests in Python. And you're going to be doing some assignments that are familiar and one or two that are newer. So we're going to be looking at Python syntax and data structures, the built-in variable types, the slightly more complex built-in types. We're going to learn how to find items in lists or dictionaries in Python and just how awesome lists and dictionaries are in Python, about error handling, a little bit about files, and then after our sort of workshop time, the second part of the lecture, we'll dive into test-driven development. So the goals for today, really writing tests, which will come later in the morning. For this morning, for this first part of our lecture, there are a number of things I'm going to be covering. Some of this will be review. Some of it might be new. I would say your goal in the lecture is really for things that are new, sort of the level 1 of understanding, where now I know its name, I know it exists, I sort of know when it might be relevant, and I know how to Google it to find more information about it. And for some of these things, maybe going from like a level 1 understanding to a level 2 understanding, which is I know what it is and I'm relatively comfortable using it. Though a lot of that will come with practice. And then the sort of level 3 understanding of like mastery of each of these concepts, that really will come later with time as you just get more practice writing code. So today is really about kind of like level 1 understanding and level 2 understanding of stuff. And what I would just ask is for now, let's put questions either in the Zoom chat or in our Google chat, just in the interests of time. And TAs, if you can maybe keep an eye on the Zoom chat for questions as they come up, that would be awesome. So let me go ahead and just kind of dive in, and we're going to do some Python review and talking about the language. So again, today is really about some of this will be familiar, some of this will be a little newer. And you can start to see how concepts are shared across programming languages. Python and JavaScript are different languages, but they share a lot of features. They're both dynamically typed. There's no strong typing. They both have first-class functions. Functions can be passed assigned to variables or passed as as an argument to another function, which, as we learned yesterday, is called a higher order function. Neither need to have a separate compilation step. However, there's a lot of differences, as we'll see as we get into it. So Python, like JavaScript, has a number type. You'll also note that in Python, unlike JavaScript, we don't have to put const or let in front of our variable declarations. And I'm not sure why that squiggly is there complaining, but we can safely ignore it. There's going to be some squigglies. Let me actually turn off my Python for the moment, because there's certain things that it won't like that. Yeah, so just ignore the squigglies. So we don't have to do, const or let. In Python, we can just declare a variable and we can always change the variable. So it is much simpler. Python also has a method named type that's sort of like JavaScript's type of. We can use to see what type of variable is. And I use the Python runtime to run my Python code on the command line. And everything in Python is an object. And we'll talk about Python objects later, especially next week. And next week in object-oriented programming, we'll learn about objects and classes. So what you see here is Python is saying, hey, this variable, a small number, well, it's an object, and the class that object belongs to is integer. And actually, if we go ahead and let's do a decimal number equals 3.7, and we do print type decimal number, let's see what we get there. And so unlike JavaScript, and I apologize if I misspoke a moment ago, Python does have different kinds of number types, both integer and float. And float is short for floating point for decimal numbers. And those are the two main number types that we need to know about. And you don't need to worry about declaring them explicitly. As you can see, Python tries to infer and figure it out, and you can change from one to another without serious issues for most applications. Python has a lot of really nice functionality around strings. We're going to see more of it later, but just to sort of intro and review strings a bit, let's create a string variable. And as you all have noted, I am using what's called snake casing to name my variables. In Python, the convention is, unlike JavaScript, where we might do this, the camel casing approach, Python wants you to use snake casing. So please do that. I know I was complaining about the squigglies from the sort of linter checker, but the more you embrace the standards of the language, the easier it is to read code. And also, everyone else who's familiar with Python, when they look at your code, is going to be expecting it to be written in that way. And again, here, the VS Code extensions are your friend because they'll help you with this. And I can do a single quote or a double quoted string. And let's check out what Python infers about the type of these string variables that we are creating. And as we can see, Python can easily figure out that these classes are strings. Python also has string interpolation, just like we saw in JavaScript yesterday, where it was the backtick $ curly bracket. But Python makes it a little easier with what it calls an F string, because we use the letter F as a keyword, and it looks something like this. And as long as I got that right, and I don't have any typos, and in fact, I do have a typo. And here the red squiggly is helping me, and it's a little hard to see, but this curly bracket is red because I forgot my closing bracket. And it looks like I have one more typo probably lurking in the background somewhere.
You tried to run that with Node, not with Python.
That would do it. Thank you so much. That is definitely part of the challenge of the context switching. and we can assign f strings to variables. Just like we can with string interpolation in JavaScript. So the last primitive type in Python that I want to talk about is Booleans, true and false. There is a lot of similarity to JavaScript, but the important thing to note is you need to uppercase true and you need to uppercase false. We'll look at Boolean logic or conditional logic in a little bit. Python is super readable, so this actually makes it really nice. And if we do print type of something true, let's see what that looks like. And just for fun, let's print something false. And Python is kind of stricter about Boolean logic and truthy and falsy than JavaScript, which is great. And we can see here that Python can infer that these variables are Booleans of class bool and just prints out false. So I just want to check in and see if folks have any questions before we start looking at lists and dictionaries and stuff. I see there was a question about opening and closing parentheses, when or when not to use them. The short answer is if you don't, the rule of thumb in programming is usually if you don't need it, don't use it. So like if I don't need opening and closing parentheses somewhere, don't add them just to sort of add like an extra layer of comfort or clarity. Every now and then with like tricky logic, maybe the extra parentheses makes the intent a little clearer, but otherwise, if it's not needed, don't use it. So, and by the way to do multi-line comments in Python is what's called, I think they call it a doc string, these 3 double quotes. And you can add multi-line comments in there. And then this is how you do single line comments in Python. So lists are sort of like JavaScript arrays, but better. You're going to be using lists all the time. And it's going to look initially very similar to a JavaScript array. And I'm just going to throw in like some fruits and veggies in here so we have a list with enough stuff to make it interesting. And if we print its type, and we run our code, we'll see that I have a typo hiding at the very beginning of my list. So let's go ahead and fix that. And let's run this again. And we see that it's of class list. Python has some very nice features for grabbing certain different elements in our list and slicing them. So let me go ahead and demo those. Right? The list is still 0 indexed, berries of 1 doesn't give us the 0th, the very first thing in the list. It gives us the first one. So the 0 indexing is a constant. If we want to work backwards through our list, and this might actually work in JavaScript as well, I'd have to double check, but I think so. We can use a negative number. And let me do some quick commenting out of our prior print statements, just so we're not seeing as much code here. And in fact, I'm just going to use Command F to find all of my print statements. And the command or control / to toggle commenting lines out. And let's comment that one out. And comment that one out. And I'll just comment these out as we go, moving forward. So we've got the basic grabbing of different elements in the list by index. We can do something very nifty called slicing. And if I run this code, let's see what happens. It starts at the 0th index and grabs it. It grabs the first one, the second one, the third one, right? It doesn't go to index 3. So if I do print berries 2, 4, what do we think it's going to grab and what's going to get printed when I run this command? What will we see in the terminal for berries 2:4?
Cucumber and eggplant.
Thank you. Let's give it a shot. Let's see what we get. Yeah, exactly. Nice. And if we want to go all the way to the end, we can just do it like this. And we can get the whole thing. So the slicing is very useful, and the slicing is non-destructive. Note that the original list is exactly the same. Slicing makes a new list and moves the stuff that we care about into it. So now let's look at a data type that JavaScript does not have an equivalent of, called a tuple. The list you're going to use all the time. The tuple you're going to use a bit less often. It's used for storing multiple pieces of related data together. Tuples are immutable. They're not meant to be changed once you create them. So you will be creating them for, the term is constants, things like that are always going to be the same. Or like you saw in the pair programming with Francisco, maybe you're looping through stuff and you need to make like a temporary variable and you recreate that variable every time. But when you create it, you never change it. So let me give you one good example of when you might want to use a tuple is for something like, say, the days of the week, because that is never going to change. And let me do a little magic here. And let's check out that type. And let's just print it too, just to see what we get. And also as a sanity check to make sure that I don't have a typo in here. And in fact, I do have a typo because I was missing a comma. And I was missing one comma right here too, which just goes to show sometimes the shortcut isn't so short. So like another good example of a tuple might be, you know, latitude and longitude or coordinate points. So a tuple is not for data you're going to be constantly changing, but maybe to grab bits of related data that you want to work with, or again, like you're temporarily creating something and then you create a new version of it, like you saw in the for loop for the Roman numerals problem. And the way that you access a tuple is like this. And if I try to change a tuple, I should get an error. And here the useful information is at the bottom. There's a type error. Tuple object does not support assignment. We can't just go in and change it. And then it gives us the line of code that's causing the error. And I want to pause in before we get to dictionaries, which are super cool, and just see if folks have any questions. Yes, I see someone's hand up.
So basically like tuples, you gave the example like days of the week, coordinate points. So is that just gonna be like, I mean, is there anything else we really use them for? I mean, I'm sure in time we'll just figure it out, but it sounds like if I know exactly what it is, then that's really the only time I'm gonna use it, is if it's something I know it's not gonna change.
You can use tuples all the time. Like for instance, imagine this is pseudocode. This is not working Python, but imagine you're working on the Roman numerals problem and you're doing item and I don't know, Roman numerals data. The Roman numerals actually is a great example of when you might have used a tuple, right? Instead of a JavaScript object, you could have some tuples in a list. You know, you could have done Roman numerals list x10 v5 etc. You know, and then there's always like when you're in a for loop, maybe we only need like certain parts of a thing. And you're never going to change this, but you're going to create a new instance, a new version of this variable each iteration through the loop, right? So you're still never modifying. There's a difference between modifying a variable versus creating a new version, a new instance of it, right? Because each time we loop through this on line 68, I'm not actually modifying tuple of stuff. I'm creating a new variable named tuple of stuff that overwrites the old one. So that's an important distinction.
That's what I was thinking, like along with mutations and such, is like you just create another one if you can't actually modify it. But okay, no, that makes sense. But with tuples, it makes sense. So you just use them. Okay, cool beans. Thank you.
Yeah, great question. And it always sounds a little trickier than it is in practice. Once you see it and start doing it, it makes a lot of sense. I saw there were one or two other questions. If you could please throw them in the chat or in Slack, the TAs or myself will get back to them later. I want to dive into dictionaries. Dictionaries are sort of like objects in JavaScript, though different and frankly better because I think they're more explicit. And a dictionary, again, is all about having keys and values, and we can nest stuff. So let's take a look at Python dictionaries. And a huge amount of the work you do in Python will be working with lists and dictionaries. Between those two things, you can get awfully far. So unlike JavaScript objects, if you're using string keys for Python dictionary, you need to put it in quotes. And unlike JavaScript objects, you can't use dot notation to access a key in a dictionary. You have to use the bracket notation approach. And again, once you start combining these data structures is when stuff starts to get really interesting. And let's make a list of our influencers. So we're making a list of dictionaries, or rather not a list of our influencers, just a list of people. I'm just going to change just the names just in the interests of time. So maybe Carol will be a bit different. And she's retired now, and she is a life coach because she's following her passion. You know, we might get a complaint about the trailing comma here. Let's see if we do or not. So no complaints about the trailing comma. I do recommend adding a trailing comma as a habit when you're using this sort of style, because a really easy mistake to make is I want to add a new property. But I forgot to add the comma. And while this red squiggly here is telling me that's super easy to miss, if as a habit you just add trailing commas at the end of stuff, you'll be set. And we can use bracket notation to go down multiple levels of our more complex data shapes that we're now creating to get the second person, right? The first person at index 1 in my list and get their name. And I just want to pause and see if folks have any questions. All right, let's talk about functions. So functions are a core feature of pretty much every programming language ever. To define a function in Python, we use the keyword def, which is short for define. Use the snake case convention for naming functions. If we had an argument, we would put it in here, but we're not quite there yet. And then you add a semicolon at the end. Python is kind of special as a language in that indentation matters. In JavaScript, that would be fine. In Python, that'll actually throw an error. And I might actually be getting an error now. Let's see if this gives us an error. So it does not, but it also hasn't run this. And can anyone tell me why this print statement didn't run?
Because it's running after the return statement in the function.
Right.
It's
Or-
indented.
Dented.
Yeah.
What does Python think the print statement is a part of?
Definition.
Print.
Yeah.
Unify function.
Yeah, exactly. In JavaScript, the indentation doesn't have like meaning to the language, and in Python it does. And thank you, folks. And one nice thing about Python is it is a bit stricter about arguments. If I create a function that takes an argument and I don't pass any arguments, Python throws an error. It gives me actually a pretty solid explanation of the error. And honestly, that is awesome because that makes our lives way easier. JavaScript's decision to just set that function argument to undefined is, in my opinion, a mixed bag. And we can have functions with multiple arguments in Python, of course. And of course, the order of my function arguments matter. And let me do a little cleanup of my print statements here, and we'll keep on rolling. Python also has something called keyword arguments, which is great. And I'm doing two things here. N equals 1, color equals blue, sets a default value for each of these function arguments. And it tells Python, hey, these are keyword arguments. I have to use this one a little differently. And actually, let me keyword arguments I can put in any order, because since there's a keyword, I can just define it however I want. And it would help if I added the quotes that Python is going to be expecting, because it was looking for a variable named red that was not defined, right? Name red was not defined because this wasn't a string. It was the name of a variable that did not exist. Two nifty features of Python functions worth mentioning, and these you will use probably less often. The rule of thumb in programming, I would say, is whenever you can, be as explicit as you can, because it makes debugging easier and it makes it easier for other people to read your code. So these things that I'm going to show you, use them with caution. In fact, I would suggest just don't use them unless you have a specific reason for doing so, because otherwise you will find your code actually becomes really difficult to debug and work with. So you can use star args for an unspecified number of ordered params. So I could create a function with as many arguments as I want. Python bundles all of that up, and I think it bundled it up into a tuple based on those parentheses. Just for fun, we could do print type args, and let's see what type Python creates to hold that stuff. And indeed, they make a tuple. So this is a bit higher level, but it's a good example of how languages are built using their own features, right? The lower level features of a language are composed and used to implement these higher level features. Don't use this unless you really need it, because it's really confusing, because when you're working with this function, you have no idea what should or should not be in here, as opposed to this function where I know, hey, it should have a color and there should be a number of berries. You can also do this with keyword arguments, with double star kwargs or keyword args, and there's some nifty Python slang for the double star that I can't remember at the moment. But star quargs, which is short for keyword args. And we can use a loop. And Python makes looping through lists or dictionaries or tuples really easy. I'm going to change this to K. The quarg and quargs are only one letter apart. And if I did this, it would cause a real problem because I'm then like redefining this variable itself. So that makes me nervous. So this is called defensive programming. Writing your code in a style that reduces the possibilities for error. I'm just going to do for K and quargs, plus K is shorter, easier to type. We'll talk more about loops in a bit, but just to kind of demonstrate it. And let me make sure I have all of my curly brackets right, because I think VS Code tried to help me and got in the way. And I think that's right, though I'm seeing some squigglies, so we're just going to run it and see if we get any useful error messages and go from there. That worked fine. And these squigglies are one of my Python extensions is giving me a suggestion of a better way to do this. And they're right, but I don't have to worry about it now. I think the takeaway here is it's worth hovering over stuff in Python. For these, my extension just wants me to add a string, a doc string comment to explain that method and how it works. So star quargs lets you have unlimited keyword options. Again, use with caution, and in fact, just don't use it unless you need to, because, you know, what if I wanted to do, how do I even know this person's age? You know, if age is less than 10, but there is no age argument. I don't even know if it's in here because you could never pass it at all and this function would still work fine. And even if I do pass it, I have to like loop through here and do something like if K is age, you know, age equals quargs K or something like that. And it's just not worth it. So again, avoid this one unless you have a specific reason where you need it. And I just want to pause and see if folks have any questions.
Hey, Adam. Yeah, I have a question.
What's up?
For the star args, is that similar to spread operator in JavaScript?
No. Maybe there's a little bit of similarity in behavior, but they work in different ways and get used for different things.
Okay, gotcha. Thanks.
Yeah. Athena, what's up?
Just for the keyword arguments, are you just setting a variable and that's the convention that it's called, or is there like a specific method of doing that? So when you're like n equals 1 and then color equals blue, like, is that just like that is just the convention? It's called keyword arguments.
Yeah, so the difference here is if I just did this, I believe then Python treats these as positional arguments, just like here. I think you always have to add a default for keyword arguments. There might be some other way, but that's my understanding at the moment. And once you add this default, Python uses the default and treats those as keyword arguments instead.
And are you only able to use like the type that it's set to? So if I were to put like a float or a string for n, would it throw me an error?
Good question. No, it would not, because Python is dynamically typed and you can change the type of a variable whenever you want.
Okay, thank you.
Yeah, totally. I see one or two more questions. If you could please throw them in the Zoom chat or the Slack chat, and please do so we can follow up. And there are probably other people wondering the same thing. I apologize. I do want to keep moving so I can cover some of the other things that we want to. And then when we wrap, I'll have a little more time for questions as well. Let's look a bit at yeah, so please throw your questions either in Whiskey or Whiskey questions or in the Zoom chat, and we'll come back to them. Let's take a look at if-else statements in Python. They're relatively similar to JavaScript. I'm going to make a function right now to figure out if someone's old enough to drink beer. Greater than or equal to looks similar to JavaScript. As you've noted, you don't need parentheses all over the place for certain things in Python, which makes the code way more readable. Instead of the double vertical lines, which is this sort of logical symbol for like a logical Boolean logic, or, you know, like true or false. In Python, we just use the word or, which frankly is really nice and readable. And here, because of the behavior of short circuiting, and it would have helped if I put the original age in there. If age is not greater than equal to 21, we jump into the or, and then it moves through this and does age has to be greater than equal to 18 and country equals Canada. If it helps you understand your code better, you could put parentheses here. They're not needed for Python to apply this logic the way that we want to, though. And I want to just point out one small sort of design principle that's useful to think about and follow, which is think about, you know, if we had it, sometimes it's easier for your first conditional to be your sort of true path or your happy path. Sometimes it's easier for this to be your error case or your false path. It's always worth thinking about which one is easier, because then it makes the rest of the conditional when you're writing it easier to go. So like this way we do all this stuff, but then we just need an else at the end. And let me go ahead and add a print statement. And let's do can drink beer, age 20, country USA. And let's do someone who's 21. And let's do someone who lives in Canada. And this is, you know, like my own sort of lazy man's version of writing tests, which is really useful to do as you write your code. It's great to get in the habit of writing proper tests, but even console log tests are way better than nothing. So these look right. If I want to add multiple conditionals, in Python, else if, they shorten it to ELIF. And we can just use the double equals for comparison. And if I can spell Antarctica right. And then at this point, I actually have two choices here. It's actually a slightly nicer. Well, I think that should work fine. And I had a semicolon in the wrong spot there. which my red squigglies were warning me about. So if we're of the right age or the US and Canada, we return true. Right? Once we've eliminated all this, the Antarctica one is easy. Otherwise, we return false. You're not old enough to drink. So according to whatever these rules are, the 4-year-olds in Antarctica can go nuts. Let me talk a bit about looping. Python has this very nice construct of the for in loop. Let me go ahead and clean up my print statements a bit. That should do it. So very straightforward way to go through all the items, the elements in a list. Note that doing it this way, we don't have an index, which sometimes we want or need. So this is a little more complex and uses what's called an enumerator, which we can get into later. But if I need to loop through something in Python and I actually need an index, because a lot of the times you might not, we have to use this built-in language feature called enumerate. And actually, let me write this out and then I'll hover over it because the description is perfect. And in JavaScript, there would be the parentheses and the semicolons. The Python syntax is a lot cleaner. We're creating a variable named I that's going to be assigned the index sort of counter, and X is going to have the value. We're creating a variable X that will have the value itself as we go through each element in our list. And we're just going to print both of those things. And then we can see this ordered out. And I highly recommend hovering over stuff in VS Code a lot because I think VS Code just grabs the official Python docs for all of this stuff. Some of this stuff you have to skip. You can see what's called the class definition or signature at the top. And iteratables and enumerables are a little out of scope for today. But towards the bottom of this is the useful bit where it says the enumerate object yields pairs containing a count and a value. And then they sort of give us an example. And so this basically you give it a list and you get the index and the value of each element in the list. Python also has a pretty neat, nifty feature. Python has so many good built-in language features. There's something called range, which again produces sort of a sequence. I think this actually will not work. Let's see if it. So range is a little funny. Being a little more used to JavaScript, I always have to reread the docs on this. Range doesn't directly give us the numbers 1 through 10. It sort of gives us this other object, what Python calls an iterable, that we can use in combination with a loop. Actually, I'll comment out from that one more time. Oh, it really doesn't Python is really strict about its syntax, so I apologize. I just have to go ahead and do that. So range is a tool that we can use if we need to loop X number of times or however many times we want. And this is basically our counter. There's more you can do with range, but we'll kind of go into it more later. You can also loop through dictionaries, both keys and values, really easily. Like just to make up another little dictionary here of, I don't know, someone who likes donuts, but doesn't like green beans. And all these variable names, I could name this, whatever I want. I just name it K because it's short for key. So I can loop through the keys of a dictionary. And here I'm printing the key, and here I'm using the key to get the value for that particular key in the dictionary. If I just want to loop through the values, I could do, and again, I could name this whatever I want, but I'm going to use this short for values. Dictionaries have a great function called values. So if I want to, I can get straight to the values. And I just want to pause and check in real quick and see if folks have any questions. Oh, I apologize. I might have been muted there. I wanted to check in if folks have any questions. Ooh. All right, let's look real quickly at while loops, and then we'll take a 10-minute break. And then there are a couple things that I want to get through, but we'll have at least a solid 30 minutes of workshop time. And hopefully, can I get a quick show of hands? Is this useful review or introduction of new language features for people? Okay, awesome. And again, the goal for today is not to instantly become an expert with all these things. The goal is just to be exposed to them, to know they exist, so you can start using them more and more and more. And what I would suggest is the way to learn stuff like this is just by writing code. Work on the assignments. And if you want to say go through all of these specifically, write the assignment, get it done, and then you can always go back, create a new branch, and see if you can refactor or modify your assignment to implement it in a different way to try out different language features. That's how I would recommend digging into this stuff, not just sort of reading and reviewing lessons and videos. And then while you're doing that, while you're working on some code, when you run into a point where you want to review some stuff to help you solve the problem at hand, then you can go to a video or the lesson material or what have you. Take it with a grain of salt because everyone, different things work differently for everyone, but that's sort of my approach. So let's take a quick look at while loops and then let's take a break. While loops are pretty straightforward in Python. I'm going to be totally honest. I dislike while loops in general because if you make a mistake, the loop is infinite and could go on forever. That is way less likely to happen in a for loop. For loops are more explicit because you're telling your program exactly how many times you want it to loop. let me comment these out so we don't get print statements all over the place. You know, if I make a mistake for my while loop and I write x is x plus 1 instead of x is x minus 1, this is going on forever. I'm going to have to hit Control C to kill it. One of the common uses of a while loop is if you're writing a program that takes like user input that's interactive, like something that has to stay running, but sort of like listening for input from a user or something else. That is a common use case for a while loop. In general, avoid them unless you cannot accomplish what you need to do with a different kind of loop. The while loop should, in my opinion, not be the first tool in the toolbox. Again, the exception being like user input from the command line or more interactive type programs. I just want to check in and see what questions folks have, because we can maybe knock one or two out and then we will take a break. So what's on people's minds about while loops or anything else that we've been digging into?
I mean, maybe just do an example, I guess, with a while loop, or you know, with the looping through dictionaries examples, because those are the only things that I saw. I was like, oh, I'll need to definitely practice those.
Yeah, looping through dictionaries, you're going to want to use a for in loop. In the interest of time, I'm not going to dig into that too much now because you're going to get tons of time doing that on the assignments. So I wouldn't worry about that one too much. You're absolutely right that that's important, and that one you're going to be seeing a ton of. We've covered a lot of ground this morning. We've really done almost a preview of the whole language. As you pointed out, Michael, some of these things are more important than others. Like you'll use tuples sometimes, but you'll use lists and dictionaries a ton. Obviously, the primitive types you're going to use all the time. You're going to be using functions all the time, both positional arguments and keyword arguments, to be honest. And there's no one right way. They're both perfectly fine. And I think the rule of thumb should be simplicity and whatever makes the most sense for the problem at hand. The only kind of rule with functions, if you start getting like 4 or 5 arguments, like if you get to the point where it might be confusing to remember what order they go in, that's a good sign that you want to use keyword arguments instead of positional arguments. Star args and star quargs, avoid unless you realize that you cannot solve the problem otherwise. But they're good to know about. If statements, you know, you'll all be using all the time. The for loops, Python is a little different, and this can take a little practice. And in fact, I do recommend having ChatGPT, or there's a tool called Code Help that I like because it's a ChatGPT bot, but it doesn't give you answers. Or just Google open in a window, or even the Python docs. Because as you're coding, you're going to want to refer to stuff. And that's what I do all the time and what every programmer everywhere does in the modern age. No one keeps all this stuff in their head, and that's not the goal. The goal is to know where to go to find it quickly. And as you work on problems, you'll practice and build up these skills. After the break, we're going to look at some of the really awesome built-in methods that Python has. We're going to look at a little bit at another way to do conditionals instead of if-else with switch case. A little bit at Python's version of arrow functions. A couple other nifty built-in things. A little bit of error handling, and then the big guy that I really want to get to, which is like importing and exporting in Python. So let's take 10. I'll throw the timer up. Please make it a real 10, and then we will dive back in. All right. Thank you, folks, very much. Again, please keep throwing questions and whiskey questions or the whiskey channel, and I'll see everyone in 10 minutes. All right, so let's continue our tour of Python. And actually, I'm going to jump around just a little bit and dive into Python modules and importing and exporting and writing files, because that stuff is super useful. So let's touch on it now when we're fresh after the break, and we'll come back then and kind of finish up our grand tour of the Python language. So let me make a couple files here to help me out. Let's do Python importing, exporting one py and Python. Actually, we can make these file names way shorter since we already know it's Python. We can just do importing, exporting one dot py and importing, exporting two dot py. I'm going to open up both of these. I'm going to use the star wildcard, which is saying, hey, open all the files in this directory that start with importing and exporting. And let's talk a bit about Python modules. The great thing about Python is by default, every file is a Python module that you can export stuff from. Python modules are namespaced, right? If you have two different Python files and you've got two variables with the same name in the different files, that's fine. From Python's perspective, they're separate modules and they're namespaced. So let's take a look at how to import and export. And the great news is it's super straightforward. And there's none of the weirdnesses that you run into with JavaScript. I'm going to make a little function here, say hello. That's just going to print hello. And a function, say goodbye. It's going to do basically the same thing. The great news is in Python, I don't even need to have an explicit export statement. Let me make sure I get this right and confirm that it works and go from there. See if I have a goof. Now this is where my file names are kind of, let me rename these actually. I wanted the file names to kind of be useful so you all would know where to go to look for the importing, exporting stuff. But it's causing, I kind of outsmarted myself there. I use the command line for most stuff, but sometimes for renaming, to be honest, just using VS Code and all that stuff is easier. And now we can open up file 2. And now this can just be import file 2. And now we can just do file, I'm so sorry, import file 1. And now I think there was maybe Python was being confused by some stuff. And now this nice autocomplete hint that VS Code is showing us is confirming that our import should be working as expected. And if I run it, Python file 2, we get hey there. So I had to go the long way around, but exporting in Python is super easy. You don't even have to do anything. It's not just functions that export this way. It's also variables. And it would help if I assign that variable a value. And gave it an equal sign. But now we're off to the races. So any top level function, variable, class that I define in a Python file in a module, we can import that whole module, this whole file, and then Python namespaces this. And for fun, we can do print type file1. I suspect it will be an instance of the module class. Let's see what Python says. Indeed. So we'll learn more about objects and classes next week, but this should look a little similar to a JavaScript object. This is really a Python object is a little more powerful, to be honest, but it is the same basic concept of it's not a dictionary, it's an object, but you can put stuff on it, whether it's values or methods, and use dot notation to access them. So that's one way to import stuff. Let me go ahead and let's make another file. If I want to use a different name, I can do import file3 as some other name that I want to use. And then finally, if I know that I only want to use certain functions or variables from another module, I can just import the specific thing I want. And when I do it this way, I am importing, I do need to get the name right because it will look inside that module for this function. And then I can call that function from inside my code, just like any other function. In general, prefer to do it this way because it's more explicit. And it makes it easier to see what other modules or files your functions are being used in. Athena, yes, I saw you had a question.
You answered it.
Oh, awesome. Yeah, in general, I always just go for explicitness. VS Code might be smart enough to figure out this. Let's see, if I right click here and go to definition. So it is smart enough. It does jump to the other file. As your programs get bigger, it might get a little trickier, but again, I think more explicit, it just makes it way easier. Jordan, yes, sir. You're muted.
Sorry, if you import the files like that explicitly one by one, can you do multiple imports? So say you had 3 functions in file 4, but you only wanted 2 of them.
Yep.
Okay.
Yeah, excellent call. Or let me rename this to the one that I want to use. You just separate them with a comma. Yeah,
Nice.
good question. Is that what you were wondering about?
Yes, I was just not sure if you had to do them one by one or if you can do them all in one line like that.
You can separate them with a comma, and then you're good to go. Let me talk a little bit about file paths, because sometimes we will need this. Note, by the way, that we don't need to add like file3.py. This is not the name of the file, it is the name of the Python module. What Python does is it looks at the file name and it makes a module of that same name, but it just drops the file extension, the .py extension. So in terms of how to interact with our file system, because maybe I need to read from a text file and I need to get the full path, Python has a built-in class called OS. And let me actually, that stuff, I'll close out. We'll come back to sort of our main file. So you do always want to put like your import statements at the top of each file, both for readability, so you only have to go to one spot to see all of the dependencies of this module. And Python might actually complain if you don't. I'm not actually positive. And then this OS library lets us do all sorts of interesting things, like it gets the current working directory, it gets the absolute path to the current working directory. And we're going to see in a moment some other things that it can do and why this is useful. Let's see. I got a couple things wrong here. First off, I want to get rid of that range print statement that's cluttering stuff up. Hang off, let's see what this error says. OS has no attribute get CWD. I misspelled it. I have OS there twice. By the way, note that it actually gave me the right answer to what I needed, which just goes to show it's always worth taking the time to read the important part of the error message carefully. Again, it's either the bottom or the top of the message. I get the line number and description of the issue. Let's give this another shot. So what we see printed out here is the absolute path to my current working directory. So if I navigate up a directory, so I'm not in that directory anymore. My intro to Python py file is inside this other directory here. But let's say I want to run it from here for whatever reason. When we get to this os.cwd command, is it going to be the same as when I ran this program from the other directory or different? Let's see, did I actually run it from both places? I did. I'm not sure why this second one was ridiculously longer. Let's see, can't open file. Oh, I apologize. It was ridiculously longer because I didn't change my path. So let's run this experiment one more time. I'm in the directory with the Python file I want to run. I run it, we print out the current working directory. I navigate out of that directory. I run the same file from a different directory. I get a different path. Because this is not the directory that the file lives in. this is the directory I am running my program from. So that's a really important distinction. This os.cwd, when the program runs, it gets you the absolute path to the directory the program is running in. And what you can do, though, I believe, if you want to get where the Python file is we can do os.path. This absolute path command. This might still give us the current working directory. Let's run it and find out. Yeah, so this is not, this is. That is still giving us where the code is being run from. So this becomes relevant for reading and writing files. And let's take a look at that. And after this, I think there's maybe one other thing I'll touch on, and then we'll break so that there's some work time, because some of these other language features are interesting, but not critical. And also something that maybe we can cover in an afternoon review session. So the question whenever you're grabbing a file from somewhere else is always, should I use a relative path or an absolute path? And let me make sure I'm in the right spot. I'll just navigate back to where this code is. And just very quickly, I'm going to put something inside that file. Python has this great built-in operator called with, and then we can use this command open. And I'm going to give it a relative path to example.txt. Open takes a couple arguments. And in fact, if we hover over it, we can see a description. It needs to take the file path. We need to tell it the mode if we're reading or writing. And then if I scroll way, way, way down, I eventually get a description of the method itself and the different ways that we can open a file just for reading, or to write the file, creating a new file, appending to the end of the file. That's a good one. That's a useful one. And then we use this as, and we tell it just the name that we're going to use. And then Python does some nice work for us, and it turns the file maybe into a dictionary or a tuple, something iteratable. I'm not sure off the top of my head, but we can use a for in loop to go through each line of that file. And in fact, let's just do a quick print type file, and we'll see what type of thing it is in Python. And looks like I have a typo. Can anyone tell me what I did wrong here? It's a little subtle, though it ends up straightforward. Tom, yes, sir.
Does the R have to be a string, maybe?
Yeah, exactly. So if I look at the error, name error, name R is not defined. That's the error you get when you're trying to use a variable that doesn't exist. And then this line above it tells me exactly where the error is, and it points to it. This red squiggly is also there. So when I look at this, I realize, oh shoot, R, well, that's a variable that doesn't exist. So of course it's going to fail. And if I hover over and look at the sort of the docs for using this open method, I see also that it wants me to pass a string as an argument, but these are magic string values, right? Only certain ones will work, which you should generally avoid when you write code, but you will see it come up from time to time when using other libraries. So now let's see if that works, or if there's another issue to debug and resolve. And there we go. And we can see there's this crazy class called io.text IO wrapper that we don't even need to worry about. The important thing is I can iterate through each line in my file. Now, if I run this Python program from a different directory, like if I go a level up, let's see what happens. Do we think we're going to read our file or not? And why is this failing?
You're using a relative path instead of explicit.
Well, I used the relative path a moment ago and it worked just fine. Why is the using a relative path not working now?
Because your present working directory changed.
Yeah, exactly. Right. This is relative to the directory I'm running my code in. So exactly, we changed the directory. And so now this relative path doesn't work because it's assuming this program is being run somewhere else. So here is why using an absolute path can be useful. This is where it gets tricky because the reality is in this situation, I would have to know where that file is relative to my code. Like I'm not gonna in my Python code try and search through the whole file system for the file I want. Which is also why you'll see very soon as we start to get bigger and bigger programs that the structure of your projects, like once we start having more directories inside our project root directory and what files are where, is really important and not something that should be like changed or messed around with because then stuff starts to break. But we're not quite there yet. So just to show how to get an absolute path, let me go ahead and show this. So what I can do is I can do os.path absolute path. And the irony here is I still need to know where the thing I want lives. So I need the relative path to get the absolute path. So this would still fail running it from the other directory, right? But at least you can see how to use an absolute path and start to get an understanding of the limitations of each approach. And then here I can just really do the same thing, except instead of this string, I pass it this variable that has my absolute path string. Let's see, what did we not like?
Did you ever switch back to the other directory?
I did, but then I used the wrong command to run the program. And in fact, the error is saying I can't even find the Python file at all. Which goes to show there is some danger in using that up arrow key on the command line. And it's also why the tab is your friend on the command line, because it will give you, if tab isn't working when you think it should, that tells me I'm in the wrong directory or using a wrong path or something. And then if we wanted to write to the file, we could do W and we could start like changing the line. And in fact, let's just try that out right now and watch what happens. And it looks like, what does my code not like here? There's probably, the writing, there's probably just an extra step that I'm skipping at the moment. So I'm not going to worry about it too much right now. I don't want to go down too much of a rabbit hole. And that one's relatively straightforward to figure out too. It's like a Google search or two away. So there might be one thing I'm missing here, but the basic idea is we change from read to write or write to append if we wanted to append to the end of the file. So we've covered a lot of ground here, and it is 10:40. So there are a couple things I'm gonna, unfortunately, I think I want to skip over, so we get a break and at least a little hands-on time before we look at Pytest. Just to kind of jump through these things, and let me actually just pull up our curriculum doc to talk through them. So there's a couple more pieces here. So I did not get to the we go over a number of really useful built-in methods. This is really valuable. The good news is this is also very straightforward. Like there is a method you can call on any string in Python that will capitalize the first letter of that string. There's a method you can call replace to replace any character in that string, though it's non-destructive, to add something to the end of a list. This is actually extremely useful, finding something in a list. And the amazing thing is all you have to do is if in, and same thing for a dictionary. If the key is in the dictionary, or if the value, or I'm sorry, if the value is in the dictionary, or if the string is one of our keys. Python has something called a match. In other languages, this is called a switch case, which is why you see case here. In JavaScript, it's called a switch case. Sometimes this is a useful alternative to if statements. It's useful when you might have like 10 different options and the logic is really, really simple. When in doubt, just use if-else statements. This is good to know about, but less critical. Python has a version of arrow functions, which are called lambda functions. This will not come up as much right now. Maybe I'll do an afternoon breakout session on this. There are some techniques here that are really valuable with these functions, map, filter, and reduce. We didn't see these yet with JavaScript. This is a bit more complex, and I might go over it in the afternoon, but this stuff is not critical for today. And you won't be using it a ton in Python, though it is good to see. The one thing I do want to show that is super useful is this dictionary zip built-in method. And let me actually just demo that now, and then that's probably a good stopping point for us. And the other reason that I want to demo this is because it highlights how, unlike JavaScript, Python has some really awesome built-in language features. So the more time you kind of spend reading about the language and how to do stuff, like the more it will give back to you. Zip is really straightforward. You can use it to combine lists. And again, it's non-destructive. Now, there is one interesting thing to note here, and this is part of why I wanted to point this out. Zip does not return a list. It returns the sort of instance of this zip class that we can do stuff with. But you can turn this into a list really easily with another built-in function called list. And actually, I'll leave that there and I'll put it right here. And now what Python has done for me is it's created tuples since it didn't just make one big list of putting all these things together. It combined the first element from each of these lists into a tuple and then built out that list. If we wanted to, we could also create a dictionary. I apologize. I think I have a typo in my code here, so let me see what I need to change. If I had to guess, I think the issue here may actually be, let's see what happens if we do letters, numbers. Ah, I have another guess. Yeah, okay. So this is actually really good to point out. Certain operations can modify a list or a variable, are destructive. Others create a copy. And this is true in JavaScript and Python. And this is a really easy, this is where a lot of common bugs, programmer errors come from. So it's always a good thing to pay extra attention to. The zip function doesn't modify either of these lists. It creates this special sort of class instance called zipped. And we can print it out. When I turn this zipped up thing into something else, this does get modified. And that's why my dictionary was empty. And if I flip the order here, if we make the dictionary first, then the list second, I think we'll see an empty list. Yep. And I got a little confused because I assumed, oh, these are non-destructive operations that don't modify whatever the heck this is, because that's sort of how zip works, but that wasn't the case. There's another takeaway here, which is sometimes like more variables, more mutation, more state is bad, because if instead of writing my code this way, I wrote it this way, I'll just keep the order the same just for simplicity. Where I'm not trying to modify a variable that already exists, I'm directly doing the operation itself, sort of on the raw data, so to speak. I don't have a problem. And this is a super cheap operation. There's like no real performance considerations. If this was in some loop happening like 100,000 times a minute or like thousands of times a second, maybe we need to care, but on a practical level, we really don't. And if that was the case, we'd probably have much more important performance considerations to think about anyway. So there's a lot to be said for this approach, because writing my code this way, I just eliminated a potential problem and source of confusion, and now my code is way less brittle. So this is probably a good stopping point, especially because I apologize, I really ate into our work time today. So I'm sorry about that. Let me stop the recording and let's take a break, and then we will start looking at testing. So we've seen a little bit about testing yesterday in JavaScript. And we're going to see more of it today. And I wish there was a way to make this go away. Test-driven development is one particular approach to writing software. It went through a period of being extremely popular. It is still relatively popular. There's 50-50 odds you will be asked about it in technical interviews after graduation. So it is really good to know about, and it is why we introduced testing. There is some hype and some real value to it. The challenge with tests is always they take time. If the test is wrong, then that's a problem. And the test can't tell you about the things that you don't test for. But testing is one really important part of software quality, along with readable code and good comments and certain kinds of tools and code reviews and stuff like that. I also think test-driven development is really useful for all of you as folks new to software engineering, to give you a process for designing and working on stuff. Because very quickly, the programs that you write are going to get bigger. And you're going to realize you have to separate designing from building, and that the workflow of how can I be productive and minimize the amount of bugs I create is incredibly important. And this approach is a little clunky, but it can be really powerful. And it's this term red-green refactor. Before I start writing code, think about what I need to do, and maybe even write out some pseudocode and comments, like some plain English sentences describing my algorithm. Pick one piece of it, like one function that I'm going to write a test for that. That will help me figure out what the code I'm going to write should look like. And writing the test will take way less time than writing the function, realizing it was wrong and I missed something, going back, modifying it, and so on. Like the more upfront work you do before you get into sort of the coding implementation itself, the more time you save, even though it can feel slower. So you write a failing test for the functionality you're about to implement. You run it, you make sure the test fails, and then you start writing that bit of code. This is not an intuitive process for most people. It certainly isn't for me. It's a learned skill to chunk up work like this. But then all of a sudden, your problems become smaller and easier. And then once your code is passing the test, if you need to, you refactor to clean it up, to improve structure, maintainability, while keeping the test passing. And the test is your harness. People call it a test harness, because when I'm maybe refactoring my function to make it better, I might introduce a new error, and that's where the test can help me, because if the test fails, I know I have a bug. And very quickly, you'll realize you can have problems in your code, but the code runs just fine as things start to get more complex. So test-driven development is really valuable and important for these reasons. Again, not every company practices it. Programmers have a wide range of strong feelings for or against. I'm somewhere in the middle, but there's no denial that testing is an incredibly important part of like software quality, which everybody in the industry cares about. And that test-driven development can provide, I think, a really good workflow for folks starting out in the industry. So reliability, documentation, maintainability, collaboration, this is less relevant, but in real world applications, a customer reports a bug, we fix it, we do a pull request, we merge it. A week later, someone else on the team is working on another feature, they accidentally reintroduce the bug. It happens way more than you would think, and it's called a regression. So what teams do is when a customer reports a bug and I fix it, I write a test for the bug. And now I have a regression test so that if someone accidentally reintroduces that bug, because bugs by definition are tricky, like if it was simple and straightforward, it probably wouldn't have been a bug in the first place, which means it's easy to make the same mistake again. And so over time, you build up this test suite that really helps you have an awesome code base that's well maintained. We learned about Jest with JavaScript. JavaScript testing is a bit trickier. There are a bunch of different libraries. There are other libraries with Python as well, but it's a bit simpler, and Pytest is really popular. And it comes, well, actually, it's not installed with Python. We're going to use pip to install it. Pytest is simple. It's powerful. It's flexible. I'm going to talk about assertions. We got introduced to them a little bit yesterday. We're going to see a bit more. There's all these really great plugins, and we're not going to really see too much of that today, but it's certainly something to explore. We haven't explored this, but test coverage is a big deal. And test coverage means, let's say I write 3 functions, but I have tests for 2 of them. Well, the code in those functions has test coverage. Like when we run our test suite, those lines of code get executed and tested, but the third one doesn't. And so Pytest and these other tools can tell us how much test coverage we have. So let me go ahead and just get this ball rolling. And just to get it started, I'll kind of do a half and half view here as we do a little bit of setup. And I'm in my directory for this stuff today. And I think I'll just make a new directory for testing, and we'll do everything inside there, so it's a little more organized. And so you will need to install Pytest. Remember on InstallFest, we created that default Python virtual environment and set it up to be always on. So that's where Pytest gets installed, and this way, hopefully you only have to install Pytest the once. But if you're ever trying to run tests and you're not sure what the issue is, you might want to do pip install Pytest just to confirm. Let's go ahead and start writing some tests. And like once we wrote them, we would just do Pytest and enter. And in fact, Pytest runs just fine. It says, hey, I looked inside the current directory. I don't see any tests. I didn't run any tests. So let's create a couple files and run a couple tests. So I'm going to create 2 files, one just example py, and the other is going to be test example py. And so for now, our convention will be the test files. We'll say test underscore example. Later on, the naming convention for Python test files may evolve. And let's open both of these up. And I'm going to do a split view so I can look at both at the same time. And I'm going to write some pseudocode first. I want a function to add 2 numbers together. I think it's going to take 2 arguments, the numbers I want to add, and it's going to return the sum. And I am going to give it a name, add 2 numbers. I'm going to use this special keyword pass in Python. And by the way, if you have a function in Python and you don't have a return statement and you just have 1 line, I believe it returns it automatically. Though don't quote me on that. But pass just tells Python there's nothing happening inside this function, and we want that so Python doesn't complain and throw errors. And the reason I wanted to make this skeleton is so I can import it. Right? Because I don't want to deal with import errors, and I don't want to deal with trying to like write a test for a function that doesn't exist. A really good rule of thumb is always try to keep your code in a working state. You should be running your code like every 5 minutes or less. You should not go more than 10 minutes without running your code. I get nervous if I don't run my code for more than 10 minutes, because if I have like 50 lines of code, but I haven't run the code, that's not work. Like your code is in one of 3 states at all times. It's either verified good because you've ran it and it's passing tests, or you've ran it and you've seen console logs or print statements that tell you it's good, or it's bad where you know you have errors, or it's unknown. And unknown is worse than bad because you don't know if it's good or bad. So your goal should be to always keep your code in a good state. Let's go ahead and write our test. And I want to use, and we write tests just by creating methods. And Pytest will run all of these methods, all of these functions. And we get to use this special keyword assert. And I don't have to import it because just like with Jest yesterday, when Pytest runs this test file, it will import some stuff for us. And we are going to assert that our function, when we call it, and we add two things to it, correctly adds two numbers together. And all of these blue and other squigglies, this is just my extensions telling me they want comments for documentation because I have it all on like a strict mode. And again, this is just like a friendly reminder. Nothing should actually break. Though, of course, this test is not going to pass. And in fact, let me do clear and let's run it again. So I run my test, red, green, refactor, red. Right off the bat, the error is, hey, we passed it two arguments, but the function doesn't take arguments at all. So let's do num A, num B. Let's run the test again. Different error. Progress. This is a really simple example, but you could imagine, say, for the Roman numerals problem, how this workflow with these really tiny steps is actually really valuable. So now I've got my function. It's got the right signature. We've got these two methods, and I'm going to go ahead and do num A plus num B. I'm going to test my theory that I don't need the return statement. I may be wrong here. I indeed was wrong. I'm pretty sure we need return because we're still getting back none. So let's add a return statement. And now we have a passing test, right? What if I made a mistake? What if instead of plus, I did A times B? My test still passes. Anyone have any thoughts, sort of like following the philosophy of test-driven development? If we've gotten this far, like, what should I do next?
Should implement a test where the product of the two numbers is not the same as the sum of the two numbers.
Yeah, exactly. And this brings up a really important point in testing, which is thinking about your data, the shape of your data, the kind of data, edge cases. This is a great example of an edge case where the sum and the product are the same thing. So let's do another test. Let's add, and I'll just add it inside this one. What two numbers should I use? Not a trick question.
You just use 3 and 2.
Perfect. Yeah, and now I've got a failure, and now it's incredibly easy to debug and fix my function, right? So I know this is a bit of a contrived example, but what are some other edge cases or cases in the data we're thinking about when writing tests for this? In addition to like when the sum is the same as the product.
If somebody uses a different type,
Yes, absolutely. Like if someone passed in a string or something like that. How about 0 true? Let's see what happens there. So that's actually kind of a combination of the 0 is its own potential edge case. So here, well, actually, I didn't do this on purpose, but I did actually make a mistake in my testing. What is wrong with these two assertion statements? Do I actually want add two numbers to return 5 if someone passes in 5 and true?
No.
Yeah, I would say no, because that is a really confusing behavior where we are trying to make a guess about something where we really have no idea if this is a good idea or not. I didn't quite get into exceptions earlier, and this is actually a good time to talk a little bit about that, about error handling. Like, what do we want to do when there's a mistake? There's a couple different ways to do it. There's try except. I actually I don't think that's worth going into too much right now, but we could do something like this if we really wanted to. If type num a does not equal, and here I'm not gonna lie, I'm getting out of my depth. I actually would need to Google how to do this, but like if it does not equal integer or float, then return error, right? We want a conditional for our error case, and then we can test that in our assertion. I'm not going to go down that road right now. This is an excellent point about the wrong type of input. I think it's a little out of scope right now for an introduction to testing, though you're absolutely right. That's something that's important to think about. What I will say is, especially when you're testing your own code, there are so many ways that things can go wrong and testing can take time. So it is worth starting with the sort of the highest value things to test. So for the wrong input type, we could do like, I think this should actually throw an error. I'm actually not sure what happens if we try to add together like 0 and true. I think this one is a little out of scope at the moment, though. You're right. This is absolutely important for testing in general. I see a hand up. I think it was Will.
Yeah. So I noticed in your testing that you use double equals instead of strictly equals. Does that really matter?
There is no such thing as strictly equals in Python.
Okay.
Yeah, because thankfully Python does a much better job than JavaScript with comparisons, and the reasons we have to use strict equals in JavaScript don't exist for Python.
Okay, gotcha. Thanks.
Yeah, it's a great question though, and honestly, that is a bit confusing. To boil it down, for Python, you can just do double equals. For JavaScript, always do triple equals, and they'll do the same thing. I am a bit curious, actually. I do want to. Let's run this real quick. Let's do like 0 and true. I am curious what this returns, or if it throws an error, what happens. Interesting that it returns 1. Yeah, so really, this is a little out of scope of today, but you can raise an error or an exception. It's again, like, because Python is dynamically typed, it can be a little trickier figuring out the type of inputs. This is a really good topic, but I know I will go down a rabbit hole, so I'm not going to open this door right now. Hit me up on Slack, and I can throw out a couple examples to share with folks later to see how to deal with wrong input types. Short answer: if wrong input type is like highly relevant and possible, then and easy to figure out how to test for. Like if we knew like we might get a Boolean in here by mistake or something, then yes, we would write a test for it. Otherwise, it may be a bit out of scope right now. But I'm so glad you brought it up because it is absolutely an important thing to think about. I would say the other things to think about here are negative numbers. And you want to think about like all the different possible combinations of your data, right? Because errors can be tricky. So a negative number and a positive number, two negative numbers. 0 is sort of an edge case, but 0 is always worth thinking about. Right, but now we have really good test coverage over all the different kinds of valid input this function could get. I have a combination of positive, negative numbers. I have this really good edge case of sum is same as the product. And I've got 0 and I've got just stuff with 0. So this is a good example of how to think about your data, right? Just start thinking about how all the different ways that your valid inputs can be combined. So let me go ahead and write one or two other functions and show a couple more kinds of assertions so that we can play with stuff. And actually, in fact, let me just go ahead and show some examples in here. I think that'll be easier. And we're not going to use this code for the moment, so I'll kind of put that off to the side. So you've seen the equality assertion. You can do it with strings as well. So that should be false. That should be true. Python is stricter than JavaScript, which is good. So this should be false. We can do inequality or not equals assertions. I can assert false is not 0. So that should be true. I can assert these are not the same. So that should be true as well. And let me go ahead and run this in Pytest to make sure I'm not getting confused about anything. And it looks like I have. What do I have that it doesn't like? Let's see here. Indentation error, unindent does not match any indentation level. It may be I just need to put this all inside one function. So I apologize. Give me
I think it's your function. You just got to delete that
oh my,
space.
there we go. Thank you so much. Thank you so much. Yeah, I had a space hiding there. Let's try this again. There we go. So the inequality assertion is just as important and valuable as the equality assertion. And you want to think about being able to test both. There is a shorthand for asserting equality. You could just do assert equal. By the way, you don't want to make tests too clever or too smart, because then it just introduces the possibility of error. There's a lot to be said for tests being a bit more explicit and dumb, so to speak, so that they're more trustworthy. We haven't talked a lot about raising errors, but you can assert to check if an error is raised. So this is going to cause a problem. Just 1 divided by 0 would throw an error in Python code. And this with wraps and captures that error and asserts that, hey, the error is 0 division error. And that can be great because there are lots of different kinds of errors in Python. And if it's not the right kind of error, I would have actually thought. I apologize. I actually would have thought that would have failed because it's not a 0 division error. But there may be something that I'm missing there. So let me circle back to that one. You can use all the normal comparison operators that you would. There's some other useful operators. What is really useful to see is you can assert that something is inside a list really easily. You can also assert that something is not inside a list. You can assert that something starts with something, a string rather, starts with something or ends with something. You can use Python's length function to make assertions about the length of a list. You can use Python's built-in sorted function to sort a list. And let me fix my typo there. Let's just say my list equals 3, 9, 1. And so on. The really interesting part of Pytest that I want to get to, and this is the last kind of major thing to touch on. And actually, let me pause and see if folks have any questions before we move on to that, because this is a good pausing point. Cool. Do folks want to do a short break before we kind of get to the last thing, or just power on through? And I'm just if I'm going to take silence as we just want to power on through. All right, let's do it.
to continue.
Let's do it. Awesome. And thank you. So the last thing I want to talk about, and this is a good one, is what's called monkey patching. And this is really useful for programs that take user input. And I don't think we've talked about this a ton in Python. You all may have seen it. But Python has a built-in function named input. And the way that programs talk to the shell is through what it calls standard input and standard output. And this does two things that's really nice. The first is my program is pausing here. It's pausing execution and waiting till I say something. I probably should have added a print statement. We'll use an F string, so that we can then see the program continuing execution. And you will be writing some programs that do this. So it is good to know. And so, we might have a function that gets user input. And I'll just comment that out, and let's write our function. And let's say this function, I'll just write get user input, just as an example. And let's say we want to ask the user for a number. And we are going to cast what the user types in, because I believe input, returns it as a string. Since everything we type on the command line in the shell is text, is a string. Since we know the user is going to enter a number most of the time, we're going to cast it into an integer and return it. Now, how can I test this? Because I can't just call like and let me import it. That would help as well. I can't just call this. Let's see. It looks like I have an assertion issue. And again, it's almost always the top or the bottom of the error message that tells you what's going on. Syntax error, unmatched parentheses. I have a parentheses missing, and then the line above points to the exact line of code. And if I look at this, I see that that's there, right? So unmatched meaning missing, and it's on line 38. So let's go to line 38 and just add that bad boy back in. Which just goes to show I should have taken my own advice and been running the tests as I was adding all that stuff. And here we have the other example that I wanted to raise, where we see this crazy error, Pytest, reading from standard in while output is captured. Because when I run this, it's going to wait for someone to type something. So how do I deal with that? How can I test that? There are a lot of different strategies. If this was more complex, one strategy might be we have a function do something with input. And maybe we call that here. And now I've designed my code to be more testable, and I've followed the single responsibility principle of one function getting input from the shell, from the command line, the other one doing stuff with it. And because this isn't waiting on anything, I can write a test for this like we've seen. But at some point, you're going to have to deal with user input or other things that are more difficult to directly test. And that's where this technique called monkey patching, as in like modifying sort of stuff under the hood, is useful. And that's where you'll see it in the class. You're going to see monkey patch a lot. So this is a good one to start getting familiar with. So this is another class basically that we can use that Pytest will give us specifically to do things like simulate user input. So let's see what we can do with this. We use a method called set attribute. And now we do have to start learning more and more about Python's built-ins, and this is a little bit of magic, which is also why it's good to see it here, and so you can use the curriculum doc as a reference. We need to tell monkey patch, all right, like Python's built-in input function, that's what we want to feed stuff to. And I do apologize because I skipped over Lambda functions. What we're doing here is in JavaScript, it would be an arrow function where we would pass the number or whatever we wanted the user input to be. In fact, I could write it like this if I wanted to. If this is maybe a little easier to read for the moment. But this is actually one of the times where you might use sort of Python's version of an arrow function, which is called a lambda function. Where instead of doing all this, we can use this shorthand lambda, and we can return a little function that returns the value that we want. So we're using monkey patch to say, hey, Pytest, when you hit Python's built-in input method, run this little helper lambda function that just is going to return the string 42 and use that as the user input. And let's see if this works. So the most important thing in writing tests is actually confirming that your test fails when it should. Because there's so many ways where it's easy to make a mistake in writing tests. So you should always, once you write a test, deliberately change like what you're asserting to something that you know will fail. And now I know that my test succeeds when it should and fails when it should, and I can have more confidence that I have a correct test for what I want to test. And let me just quickly show two. Well, actually, this is a good time. Let me pause and check in and see what questions folks have. Athena, a great question about the lambda. It does signify that underscore does signify an empty space. And let me actually just touch on lambdas really quickly since we did introduce them. And let me just demo them over here in example PY. So we're all familiar with regular Python functions. The same function as a lambda function looks like this. We don't define a function. but we need to some way, sometimes we want to save it, so we're assigning this lambda function to a variable. We use the keyword lambda. The first thing, Athena, as you correctly pointed out, is the input, the arguments. The colon separates the arguments from the body of the function. And then we just have a one-line statement of what to do and what gets returned.
So if you're waiting for input, you would use an underscore in place at that point?
So underscore is just actually a convention. Let me go ahead actually and run this. Actually, that's a very good point as well. Thank you so much for mentioning that. Let me just add 2 with 7. And let me go ahead and run example py. So I could change this to an underscore and change this to an underscore, and it should work just fine. Underscore is a perfectly valid character for a variable name. So Athena, again, thank you so much for mentioning this, because I didn't touch on this. The convention in Python is that when we have a function argument that we don't care about, use underscore, or if we have a variable that we don't care about. And the reason we need to do it here is because the syntax of how to create a lambda function, I think it requires at least one argument. Like if I did this, I'm pretty sure we're going to get an error. I'm not 100%, but I'm pretty sure. Yeah. And let's see here. Python lambda 2 arguments. And like the way to define a lambda function with 2 arguments is like this, with a comma. So again, there's no way to define a lambda function that has 0 arguments. And every now and then stuff like this pops up in Python. So the convention is if we need an argument or a variable, but we don't care about it, name it underscore. And that tells other programmers, this is a placeholder, ignore it. Does that make
Adam,
sense?
I got a quick question specifically about that.
Yeah.
The error message that it threw was because you had an argument passed when you called the add to function.
Oh.
And so I would like to see it without
Yeah.
that. It might work without a.
Yeah. Great idea. Let's see if I have to eat my words here.
You're gonna have to get rid of the X in there.
Of course.
First.
Thank you. Thank you, folks. Let's see what happens. Oh, so that actually does work. I apologize. I went off on a tear there, and actually I learned something new about Python. So we totally can define a lambda function that way. Yeah, thank you. Thank you guys so much. I think that was Jordan, and I apologize. I didn't catch in the Zoom who the other person was pointing out. I had to get rid of the extra X. I do want to see here in the test. The other thing actually is Monkey Patch might get unhappy about not passing an argument in, but I'm not positive. Yeah. So, I apologize, folks. I jumped to a conclusion there. The underscore is definitely, that's still like the convention for a placeholder, but it's there for a different reason. I was totally wrong. You absolutely can do this is a lambda with no args. You can make a lambda function with no arguments. You can do a lambda, with 2. I think what's going on here, and let me make sure I don't have another error creeping in. Yeah, if we run this again, and let's look at what this error message says. So this error message says test get user input, blah, blah, blah. Lambda takes 0 arguments, but 1 was given. So the issue here is actually that what monkey patch expects is a function that takes an input. Like if we comment this out, let's see what happens. Oh, and it's in fact the same thing because this doesn't take anything. Man, x equals 42. Turn x. Yeah, this thing I'm not gonna, there might be some other issues I'm running into here, but I am about 75% sure that the reason we need the placeholder here is not actually about Lambda, but about monkey patch, because the way it's designed is so that like it can send input into stuff for flexibility. Like there are ways where we could use monkey patch to maybe like dynamically pass in arguments to do different stuff. If that, does that sort of make sense to folks? And Brian, yes, what's up?
Real quick, sorry, a little off topic, but will there be a deep dive lecture at some point into how to use VS Code's debug tools with JavaScript and Python?
We can set up like probably optional afternoon breakout session on it using the debugger. I actually have never used debuggers a ton. I always just use print statements, but some people love them and it's definitely a good thing to learn about. And I think Kara, yes, what's up? Is it
Yeah, I
Kara
was just
or-
wondering, it's Kara, yeah.
Okay, perfect.
Do you think that monkey patch is having an issue with that because monkey patch itself is taking an input, so the lambda is trying to run with an input?
No, I'm pretty sure because this lambda, what this lambda is like returns. I hate using the word return in a variable name. It just makes me nervous. Let's do get. Let's and then if we put that there, this should work fine. Yeah. And then if I remove this, we should get the error. I think if I'm understanding, is this sort of what you were wondering about, or I might have misunderstood your question?
No, I think that answers my question.
Yeah. Yeah, the issue here, and this goes a little bit more into like how tools like this behave. Like here, actually, if we hover over the definition, you can see that for this set attribute method, the first argument is the target that tells it what Python thing monkey patch is going to monkey patch. Let's see here. Though they do, it's interesting because they do just have. I am not 100% sure, to be totally honest. I am actually not 100% because I also see here they seem to use a lambda that just returns something. I'm not positive, to be totally honest, what's going on there. So you guys raised up a good point. I'll dig into it a bit and investigate. It's because it is a good chance to learn and dig deeper into stuff. The most useful takeaway is probably the point that Athena raised, because every now and then, even in normal functions, you will see arguments named underscore. So that is a good thing to know. And I apologize for the confusion, and I'll kind of dig in and follow up with what was going on there. I just really want to quickly simulate, like dealing with multiple user inputs, just so we can see what that looks like. So let me go ahead and write a function, and then we can monkey patch that one out. And let's just say we're doing the same thing as we were before, where we're going to get the user input, that's going to be a number, and cast it into an integer. And then return the sum. And then we want to test this. And this is a really good discussion around monkey patch, by the way. This is exactly the kind of level that you all want to keep digging into. And I apologize that I'm pressing pause on it now, and it's only in the interest of time. And what we can do here is let's actually write a little list that's going to simulate the user input. We're going to use a somewhat fancier Python language feature named ITER, short for iterator. And if I added the equal sign there, it would help. And what this does is I am not 100% honest I'm not 100% sure, to be honest. Python has some pretty powerful sort of classes named like iterator and enumerator that basically let you tell Python that you can loop over stuff. And that's how we can get the really nice like for loops and like searching for stuff in loops without all the JavaScript clunkiness. So this is essentially sort of like a setup step so that some of that stuff can happen. But let me just go ahead and finish this up so we can see how this gets used. So I apologize that that is a little bit of magic right now. I'll try to follow up on that one as well. So again, we're telling monkey patch what it is that we want to monkey patch, and we're passing a lambda. And this time, and the ITER is probably for this next, in fact, which is again a little bit more magic-y. Because what this is doing, without going into too much depth, is it's sort of creating a loop somewhere else away from this to keep track of what we've done, so that each time this gets called, it moves on to the next one, and we don't need to like write our own loop to do that for us. So this is a little bit of Python magic. And here, this argument, well, actually is still not getting used. So yeah, that one I will come back to. And here we're gonna call our multiple inputs function, which I need to also import. And this result, let's go ahead and see what we get. And let's see if I wrote this correctly. And so I know there's a little bit of magic in here, especially this iterator and next stuff. And this can be good to dig into a bit. Again, VS Code is our friend here, because while I don't understand this entirely, to be totally honest, because so much of my work is with JavaScript, which just doesn't have any of these great features. Again, what Python is basically doing is it adds some extra abstraction and complexity to give us more power. And what we see here is this next function. What it'll do is when we give it something that's an iterator, it'll get the next thing, and the iterator keeps track of what the next thing is. So I don't have to like write a loop or counter or anything like that. So it's a little fancier, but it's pretty slick because it lets us call monkey patch, call this function, and then when our function over here gets called, every time this input function gets called, monkey patch says, hey, call this lambda. And the lambda function says, hey, iterator, give me the next thing. So to walk through this again, we run this test, we create a list of the 2 inputs we're going to give with 2 different input commands. We turn that list into an iterator. We tell monkey patch, you are going to monkey patch the input function. You are going to replace what it normally does with this other behavior. And the reason the lambda may need an argument here is to match the input function. That's my suspicion, because the input function does, I believe, require, I think it requires an argument. I'll follow up on that. But monkey patch is saying, we're replacing input. Wherever you see input, run this lambda. So these two have to match up. And so we hit the first input. Monkey patch says, lambda, do your thing. Lambda says, iterator, give me the first thing, which is 5, and then that gets set here. This flow of execution continues here. And this is a good example of where like using a debugger can be useful to step through this. We hit the second input. Monkey patch says, hey, we're replacing input with the lambda. Execute the lambda function. The lambda function says, hey, iterator, give me your next thing. And through the magic of Python iterators, it gives us the next thing, 7. And that gets passed in here for num2. The flow of execution continues in our function, and now we add the 2 together. This is returned, and then we do our assertion. So there is some complex stuff going on here under the hood. It's not critical to have like a level 3, 100% understanding of all this stuff. Though the deeper you can go, the better. On a practical level, the most important thing is being comfortable enough with monkey patch to use it for the simple use cases we've seen today, particularly just one input. And also because we use monkey patch in the tests that we write and give to you for assignments and the assessment. So this way you're familiar enough with it that when you see our tests, you can understand enough of what is going on to be able to look at that test and interpret that code. So that's really the big picture takeaway with monkey patch and all this stuff is sometimes you might want to write a test with it for the simple case, every now and then maybe for multiple cases, but you're going to see it in our tests. And this way, when you're looking over our tests for assignments and assessments, and you see monkey patch in this, it's not just 100% magic. Awesome, folks. This was a really good discussion and a really good session. Even the things that I went off track about, I think like we got to dig in and look at some interesting things. I just want to check in and see what questions folks have. Jordan, yes, sir. Or Yama.
Let's see. So monkey patch, that when it's used here, that's just a conventional term, right? That's not a keyword. That's not a specific keyword, or does it actually have to be explicitly monkey patch?
Oh, I'm pretty sure it has to be monkey patch.
Okay, so it has to be. You couldn't, if you rename that, say like monkey.
Yeah,
and then,
that's a good question. I'm pretty darn sure. Let's find out. On a practical level, yeah. There is a little magic going on under the hood here because we're not actually importing out anything. So this might be a named function argument, is what this might be. If I had to take a guess, that would be my guess that this is a named argument. But monkey patching is a thing. So there's a couple things here to consider. The first is that yeah, I don't know exactly where the monkey patch like module lives, but it's part of Pytest and it's named monkey patching or named monkey patch. And the other thing, and this is actually a really good thing to point out, is that monkey patching is a concept that is not unique to Python. This idea of like kind of like getting in under the hood and like replacing how code is supposed to behave when it runs is a general concept called monkey patching. You see it with this other language, Ruby and Ruby on Rails. You used to see it more often with like Chrome or browser extensions. It's still there because actually with JavaScript in the browser, you can, if you wanted to, you could like have a browser extension to monkey patch how every single website looked. So it's a general concept as well. So both, yeah, this is a really good question, Jordan. Both because it breaks if we don't name it monkey patch, and also because that's what this like Pytest model is called, and because that's like the concept, you just want to keep that the same for all those reasons. And also, and this way also when other programmers look at your code, they understand what this is. Yeah, great question. Let me go ahead and stop the recording.